Hi and hello all. Let us talk about benzilic acid rearrangement. In this rearrangement, a molecule like this, that is a diketone, 1,2-diketone, this molecule is actually benzyl, will react with KOH or an appropriate base, will convert into salt of benzilic acid, which on protonation will give you benzilic acid. This molecule is benzilic acid. Any rearrangement of this type is known as benzilic acid rearrangement. So in benzilic acid rearrangement, a 1,2-diketone gets converted into alpha hydroxy carboxylic acid in presence of a base through a rearrangement. So let us have a look at the mechanism of benzilic acid rearrangement. This is benzyl and this is OH minus. This is the negative center and this carbonyl carbon atom is the positive center. Now OH minus attacks this carbonyl carbon atom. So that's what shown by the indicated by this curved arrow. And at the same time, when there is a new bond is forming here, an old bond will break. This bond will break. That is indicated by this curved arrow. So this is going to be the new bond. The OH attacked this carbonyl carbon atom, and this old bond broke this pi bond, and now this becomes O minus. So now look at this oxygen. The two electrons are going to be shared. The two electrons in this oxygen is going to be in this bond now. Both electrons belonged to oxygen now, but once it's in a bond, one electron belongs to this carbon and only one electron belongs to this oxygen. That means oxygen lost one of its electron, so O minus will become neutral. So OH is neutral here. Now consider this carbon and this oxygen. The pi bond is in between these two nuclei, and that contains two electrons. And conveniently, we can say one electron belongs to oxygen and one electron belongs to carbon in that pi bond. Now when it's breaking, both electrons are going to be on oxygen, or the maximum probability of finding those electrons is going to be on oxygen. That's what indicated by this curved arrow. So oxygen got its electron and oxygen got carbon's electron too, because both electron is on oxygen now. That's the situation here. So oxygen got carbon's electrons too. So neutral oxygen got one extra electron, so it will be negatively charged. Now we could show the curved arrows here to visualize the next step. So in the next step, these two electrons come back to regenerate the pi bond. So there is going to be a new bond to this carbon, that pi bond. Now old bond has to break. So this OH could break, but that's basically the reversible reaction. That happens, but at times this rearrangement happens. That is the forward reaction. Now O minus comes back, or the new bond forms here. The old bond, this carbon-carbon, that's this bond to this phenyl group, breaks and it makes a bond with this carbonyl carbonate. So at the same time, this bond breaks and both electron goes to oxygen. Okay, let me explain that again. A new bond is going to form between this oxygen and this carbon. This old bond is going to break, and these electrons are going to be responsible for a new bond from this carbon to this carbon. That is shown by this curved arrow. Now at the same time, there is going to be a new bond to this carbon, and so the old bond will break. The pi bond will break. Both electrons will go to oxygen. So that transfer of this phenyl group from this carbon to this carbon happens. So that can be indicated with the transition state. So this is the transition state. So we could show it like that. This new bond is forming here. That's the beginning of formation of this new bond. This old bond is breaking. There is a weak bond between this carbon and this carbon, and that means a new bond is going to form here. That's a beginning of formation of a bond. Now this old bond is breaking. This is breaking, and that means both electrons are going to be on this oxygen, and that process is just getting started. This is weaker bond. So this could be the transition state. This negative charge could be, we could show the negative charge to the whole species. Now, when that happens, we have this rearrangement. Actually, we could show it with the, rather than a reversible arrow, this is an irreversible arrow. So this happens, and we have this rearrangement. That's, see, this phenyl group is now bonded to this carbon. So this phenyl group is now bonded to this carbon. It was bonded here. Now it is bonded here. Now anyway, this carbonyl, this pi bond formed, and that's the pi bond. That's the new pi bond, and this O minus is the old O minus is the this is O, this is the O that became O minus. and this is the species. This OH will pick up the proton from here because this H is much more acidic than the OH here. So this could easily pick up the proton here, and we could get a salt of the benzylic acid. So what happens? This O minus picks up this proton. This is more acidic proton, and there is going to be a new bond between this oxygen and hydrogen. That is this new bond. Both electrons in this bond is coming from oxygen, but once it's in this bond, one electron belongs to oxygen and the other electron belongs to hydrogen. At least that's how we consider to assign formal charges. This oxygen becomes neutral as it's losing one electron. That is, it was negative and it lost one electron to hydrogen. So it is neutral now. This hydrogen, say it gained one electron, and while it lost one electron here, so it doesn't, there is no net change of charge on this hydrogen, so it remains neutral. How about this bond? One electron belonged to hydrogen and another electron belonged to oxygen, but now both electrons are on this oxygen. So oxygen got one of hydrogen's electrons too, so it will have an extra electron. A neutral species getting an extra electron, making it a negatively charged species. So this oxygen is negatively charged species. This is nothing but the carboxylate ion of benzylic acid. This O minus can be protonated using adding, you can add another stronger acid. By adding another acid, mineral acid, a stronger acid, that can be protonated, that salt can be protonated, and benzylic acid can be obtained. So that's the mechanism in benzylic acid rearrangement. Let me go over the reaction once again. In benzylic acid rearrangement, OH minus attacks this carbonyl carbon atom, and this becomes O minus, that is shown here. Now once it's here, O minus again forms a pi bond here, and the old bond, this bond will break, and rearrangement happens, and now this carbon will be bonded to this carbon, and this will become O minus. So it goes through a transition state like this. This is the transition state we can show, and then it becomes as the transition happens, this phenyl group is now transferred to the other carbon. There will be a negative charge on this oxygen, and that will pick up this proton, which is the most acidic proton in that molecule. So intramolecular, we can assume an intramolecular reaction here. So we will get a salt of the benzylic acid. Protonation with a stronger acid will lead to benzylic acid. Hope you understood what is benzylic acid rearrangement and its mechanism. If you have any comment about this video, please do comment below. Thank you.